video is about Newton's second law of motion. Force is equal to mass times acceleration. Remember, acceleration is when an object changes speed, direction, or both due to an unbalanced force. Observe, this apple is not accelerating. That's because an object at rest tends to remain at rest unless acted upon by an unbalanced force. I'm now going to accelerate this apple. Notice that when I threw the apple, it did not go in a straight line. The reason for this is because the apple was acted upon by the unbalanced force of gravity that caused the apple to travel in an arc. Notice that the apple stopped when I caught it. Why did it stop? That's because I acted upon the apple with an unbalanced force. That stopped it. Another way to think about Newton's second law is how much force I apply to the mass. It turns out that objects accelerate in direct proportion to the applied force. A little bit of force, a little bit of acceleration. A lot of force, a lot of acceleration. However, what would happen if I changed the mass? According to Newton's second law, objects accelerate in inverse proportion to their mass. This time, I'm going to try to accelerate a rock with my arm. As you can see, I am unable to accelerate a greater mass with the force from my arm, the same way I could accelerate the apple. Now I would like to introduce you to the concept of the Newton. The Newton is a metric unit for force. It is defined as the force required to accelerate a mass of 1 kilogram at a rate of 1 meter per second squared. This apple does not have a mass of a kilogram. It's got a mass of about 101 grams, which is the typical mass of a regular apple. In Earth's gravity, this apple is going to accelerate at a rate that when it hits my head, it will hit my head with a force of about 1 Newton. Ready? Wasn't that fun?